Bueno, seguimos sin pausa con la siguiente presentación.
Okay,
Que
it's my time. Okay, let's start. Let me apologize because I don't understand very well your language,
don't
but
worry,
okay.
feel
Okay.
comfortable speaking in English. Uh, tell us where are you from and
I'm from Brazil, and can you see my presentation?
yes, perfect.
Okay, I start. Hi, my name is Nelson Rodriguez, and I am a student at the Federal Institute, and today we present the work entitled like Study of the Impacts of Inserting Distributed Photovoltaic Generators in the Protection of the Energy Distribution System. Okay. Let's starting by talking about the world's energy matrices and comparing to 1966 with that of 2019, we realized that hydropower remained at the due to other crease and their implementation difficult, okay? And the pollutants such as coal and petroleum have reduced, okay? And there is a large growth in the search for renewable source of electricity nowadays, okay? And the solar specific has stood out in low voltage networks as it's more available for common consumers, okay, reducing the bill value. And in this scenario, the concessionaires need to invest in research and technologies to mitigate the impacts of insertion of these cells in the electrical power system. And here we have listed some protection devices used in the system. It's common, which in the presence of faults must act protecting the network and isolating the faults, okay? This one is the fuse switch, and its function is to protect the system against overcurrent, okay? The recloser restart the system and protect it during faults, faults like transient surges, and these have 4 times to operation, too fast and too slow. Section analyzer, it sections the system and help with maneuvers. The digital relay usually are installed together with the circuit breaker with CTs too, and it shuts down the network during overload or overcurrent too, okay? On this slide, we have the characteristic of the electrical distribution system, okay? It's radial arrangement. So in that old model, the power flows in only one direction from feeder to load. Okay, we can see the logical of sequence of the device of protection in the line and the position of the loads and in extreme, okay? Uh, Here we have an example our protection. The protection must be designed with a view to coordination and selectivity. And in this example, we notice that in the case with selectivity and coordination, only the folding section was isolated, okay, different from the other. So we can conclude that the selectivity is about the characteristic of the faults when the device of protection have to activate, and the coordination is about the sequence of activation, okay? And here we have the short circuit calculation that OpenDSS uses. This is the free phase case and the single phase. In this case, the phase to earth, okay, short circuit. And this is the system that was used in the simulations. It is available in the OpenDSS library. Okay, and in this first simulation model, a DG was inserted in the main branch of the system, and its penetration was being varied, okay, increasing along the time. More precise, okay. This is the accommodation capacity of the system acquired through testing, okay, and these are the graphs plotted through the simulation on that model that I presented before. Okay, and in this first line or row, we can see the variation potencies. So the active power tendency is to decrease along the time, although the reactive after a certain point tends to increase due to reactive compensation. And if you observe, after a specific penetration, a reverse flow begins to arrive at the feeder head. Okay, remember that the DG supply only active power. Okay. In the second row, we see that this improves tension levels to some extent, then starting heavy overtensions on the line, okay, violating the limits imposed after breaking the capacity of accommodation. So over this capacity, the system must present some problems like overtensions, okay? And finally, in 30, we have the losses that also tends to increase in the presence of the reverse flow, okay? It's worth mentioning the characteristic of parabola, and it arises from the squared current in the equation of losses, okay? Zi squared, okay, the equation. And this is the calculations of short current, okay? And this is the old model with only one feeder, where the short circuit current decreases along to the distance. But in this new model that I'm presenting, with more than only one feeder, due to the generation being close to the load too, it tends to increase. And also because one of the things that influence the magnitude of the short circuit current is the generation capacity of the system. Okay, with more capacity, more current flowing in the system. Okay, this test is other one where this test was carried out with a virtual reality where each head dot represents an accumulation of photovoltaic generation. Okay, and from this model, the load shape was extracted, where we can observe that the effect of that the peak of photovoltaic generation differs from the time of the greatest consumer demand. Okay, and it facilitates the appearance of the reverse flow because think there is high generation and a low consumption. Okay, and that's photovoltaic generation, because that the photovoltaic generation is unable to make the apps less robust since the calculations are made for the worst case scenario, in this case at rush hours. So we can insert the batteries in the system to move this peak of generation to the rush hours, and the things gets more interesting, okay, for another research. And the question is, what can this do to protection? Okay. And serving data from the simulations and searching the literature, some of these impacts were listed here to us. Okay. Like in the relays, the directional relays don't sensitive against faults current in the opposite direction, and the bidirectional ones can act at inappropriate moments, isolating the sections beyond the fault. And this is very bad to the concessionaire because they have to pay a ticket, okay, for that violation. The fuse switch in some point of the lines, the fuse connections may burn out with more current flowing in it, okay. Therefore, they needed to be resized or replaced for a sectionalizer, and the sectionalizer have more capacity, okay, of current. The reclosers, they are very hampered by voltage levels, and during the operation, that 3 times that I said before, during the faults, the DG tries to maintain the short circuit because the DG operates like a source, remember, okay, and causing a failure during the recloser operations. Okay, turn off the system in appropriate moments. This is the generator's case. Is a specific case because the sudden drop in voltage during faults affects the functioning of the generator, and the impacts change that I presented before because due to the inductive characteristic and rotating load, this generator can present some specific comportment, okay? Uh, for example, induction generators contribute to fault currents because at the time of faults, they can continue to operate as a function of the residual voltage. Okay. And the conclusion is this article presented the impacts and behavior of protections in face of the increase in the G penetration, showing that the problems start to appear when there is a reverse flow of considerable power. Okay. And it explains the importance of research and studies before the inclusion of the DG in the apps to mitigate the damage and guarantee the quality of the product and service. This is the reference, and thank you very much. Okay.
Thank you, Nelson.
10
Just in
minutes?
time, 10 minutes. The, certainly, energy grids are not my area, but I will ask you about when, um, how do you generate the models and the analysis? What are the computational tools you use from a software
I
perspective, from a computational perspective?
was using the software OpenDSS, okay, operates through or by Python, with Python, okay, and was, how can I say, was used the system available at the OpenDSS store. So it's something like that because this programmation have a specific models and characteristics that differs that programmation from another ones. Like models for generators, you have to model the generators like a specific thing. So it's very hard to explain that that part.
And
But
and
photovoltaic, if you think it's like a generator with the factor power of power units are like one because it supplies only active power.
Mhm. And for modeling the photovoltaic generation, do you use real data from a certain region, or you are generating simulated scenarios?
The system come together with the data from the library of the OpenDSS.
Okay.
So we have all data from the reality. It's a big system. It's like a big city. Okay. So I model from this. Uh,
It's an
it's
open
something
source
like
data
that.
set.
Yes, the software have a library with some data and system to test cases. Okay, like cities or tests for literature, just literature or practice cases. It's something.
And if you have to summarize again the impacts of distributed photovoltaic generation for the protection, would you say that we have to consider things in the policy before deploying the photovoltaic generation, in retrofitting the current grid? What are the main engineering considerations from now on for the future of distributed generation?
The focus is it's possible to predict the comportament of the electrical power system without studies because like I show in their presentation, uh, the comportament can be different for different areas of the city because the system change the accord of the area. So if you put somewhere, you have to study that because it's impossible to predict this comportament before the without studies. Okay, because you have if you put a big power, a big potency in the photovoltaic generator, you can violate the limits of current and voltage in the system. You can cause some damage in the lines, like fire or short circuit or explosions. I just something like that.
Could you say something about how is Brazil going about this thing of photovoltaic generation in your
I
region?
I can't understand the first.
How is Brazil doing in these things of
The
photovoltaic generation? This is a real issue for for electric
no
engineers in Brazil.
no because the I don't know how to say jurisdição in Portuguese or jurisdiction.
Uh-huh.
The politics is very complicated in the Brazil,
Hmm.
so it's not a reality today, but it's reality in Australia or other countries around the world. But today, the houses of Brazil, it's not appropriate to install a photovoltaic generator. The city can't stand something like that. It's very poor people around here.
So you're
Understand?
looking for the future.
Yes, we are looking for the future or another countries like USA or Australia, some places around the Brazil, America have these technologies already. Alemanha, I Germany, the Germany is the top one in the world in something like that is reality there. Okay.
And if you consider another kind of renewable energy generation, like for example wind, and not only solar, the impact would be different.
In this case of wind, it's close. It's the same thing, but the solar it's more viable for common consumers because this occupies less space. Do you understand? Something like wind need 5,000 meters to install something like that, and it need a specific place to install. So it's impossible to bring that wind generator to the cities or to the common consumers. It is something for the companies and something big than the people. You understand? So it's very difficult to implement this in a big scale. So, but the generators like a motor induction or synchronous motors, it's different the impacts because these increase the impact because the short circuit current that it causes, it's very, very, very bigger than the photovoltaic generator. So the photovoltaic generator is used in the studies because it's more common, viable for population, it's increases, will increase more along the time, and the short circuit is considerable. Understand? It's difficult. Someone have a motor in house. Okay.
So we need a specific model for each source of energy.
Yeah,
Many
it's
differences.
difficult. Yeah, yeah, it's difficult.
Okay, thank you again, Nelson, and
Thank
we
you
are on
very
time for
much.
the next one.